One of the most enduring myths about the microprocessor industry, one that no doubt arises from its defining role in high technology, is that it is an electronic business. Anyone who has visited a clean room where microchips are made, or the one who has observed the pipes that spurt from the roof, will quite agree that the making of microprocessors, like all other devices, is more or less a chemical business. It is very much closer to printing and plating than to the process of constructing computers. And it is just this distinction between image and reality that has confused generations of layers, politicians, corporations, and other bodies. One can be sure the modern microprocessor is the product of tremendous amount of computer power, from computer aided design to manufacture of goods through computer control as also to computer testing. The best way to understand how they are made is to see as two ways of creation that meet on the floor of a clean room in a fabrication factory. By the beginning of the Second World War, the vacuum tube was very popular. Giant companies manufactured vacuum tubes and hit the business all over the world. The performance of the vacuum tube was already falling short. In fact, a replacement was found to be of utmost necessity. At that time, the new technology called data processing came on the scene. It exposed the shortcomings of the vacuum tube. Thus, the first modern computers built in the early years of the war were used to perform computations. They largely assisted the business community and the corporate world, but they were extremely slow for the applications they were designed for. Also, because they were mechanical, they tended to break down after only a few computations. The obvious answer was to go back to vacuum tubes. One of the earliest and well-known tube computers was constructed by a team of a leading university. Though it was less powerful than a modern calculator, it came at a time when it was found to be a monumental advance. Unfortunately, it was also a monumental piece of equipment. It occupied a room of the size of a warehouse. It contained thousands of vacuum tubes and ran at a very high degree of temperature. Once in every few minutes, one or more of the tubes burnt out. It required a very efficient team of technicians in bathing suits to be always ready to attend to the constant need of finding and replacing the darkened bulbs. All of those tubes consumed at a lot of power as well. There was a joke those days that every time the computer was on, the lights in and around the area dimmed. Unfortunately, the joke was not far from truth. Obviously, this situation did not last for long. Once again, as the need arose, a solution was found very soon. In another turning point in the history of technology, three researchers were looking for a way to get around the power consumption, heat loss, and fragility of the vacuum tube by creating a switch in solid material. As a matter of fact, the answer they found relied very much upon the application of power. It was then that the new device called transistor came handy for the scientists. While on the one hand, they conducted a number of experiments, they met with a number of failures on the other. Ultimately, they came out with a real success and they were awarded Nobel Prize. The transistor was small, it operated forever, and it required very less power than the tubes required. As the number of pieces that was required was very large, the manufacturing experience increased and thus their making became cheaper and cheaper. A few years later, a number of experiments and researches conducted by scientists helped to bring out an innovative device. That device, instead of having only one or even a number of transistors on the chip, contained a large number of them put together into a single integrated circuit. For easy understanding, it can be described as a number of transistors on a single chip. Even after 3 decades, the same process continues to evolve, and it is very likely that the same would continue to enter into the next century. Although the modern microprocessor may perhaps contain several million transistors, almost all of their modern design features are more or less the same. Only thing they need is improvements and elaboration. Within the next few years, a number of companies in the industry would take that basic technology and add to it other design, fabrication, and packaging techniques. By that, they will be able to produce a wide array of computers for different applications, including logic, memory, and data flow management. Thus, this large scale integration of a large number of transistors, each doing the job of a single large mechanical switch, has made the first microprocessor possible. Compared to an automobile factory, the microprocessor facility is a very small one. It is not bigger than a three-storied office building. But the process is very different. The chip is half the size of a postage stamp. It has features quite smaller than a bacteria has. To work in such a world, powerful lenses and very fast computers are very much essential. It also requires an unequaled cleanliness. A dust particle or the flake of dead skin may perhaps have the same effect as a huge crash into a planet. This clearly shows that that world is very different. Workers wore different dresses. In the early days, the manufacturers were having very primitive methods. But in later years, the modern companies put up such facilities as not allow even a single dust particle to enter into the facility. Thus, a one rooms were built for manufacture of the devices. Still, hazards are likely because of human element. Therefore, the scientists and researchers recommend that the best solution in this case would be to simply get rid of the people and replace them with the robots. But I feel, my dear friends, we are all human beings, and so we cannot get rid of the people who are our brothers and sisters and who is our labor.